Okay. I'm gonna also record this to have it as a backup. Things happen usually. Yeah, so we are live. I'm gonna add you here. Okay. Okay, Liviu, you're muted, just so you know. Cool. So I will leave the stage to Liviu. I see no better person to talk to us about HTTP 3 than Liviu. In my latest talks, I always say to people that it's kind of hard to keep up. Like you have HTTP 2 just now, and they're talking about HTTP 3. So Liviu is here to make it clear. So Liviu, you have the stage.
Yeah, thanks. Yeah, things are moving fast. Let me start. Okay. So back in, I think, 1998, there was HTTP 09 and good old days. Everything was clear, ASCII. And yeah, the protocol evolved. We got a newer version, we got additions, we got methods. It was separated in headers and body. The response got status. And yeah, the protocol is like request and response. So the client sends a request, doesn't send another one until it gets the response from the server. So yeah, it needs always to wait for the response to come back. Yeah, you have some examples here, but back then this was simple. It still used a lot HTTP 1.1, but more in internal networks, let's say, and we'll kind of see why. I need to click it. Okay. One of the things. So I'm an SRE, like working in reliability. I take care of productions. We do the op stuff in DevOps, things like that. And one of the questions that we ask usually during interviews is, what happens when you type something in the browser address, like google.com or something? You type something, what happens behind the scene? And yeah, it's not a problem, like if you get prepared for this question, because like the amount of details you can get into are very big. So like if you get prepared, you learned a lot, which is good. So it's not a secret question. So please do look it up if you want to get into a DevOps SRE interview. And some of the things that are happening there is, after the kind of like the name resolving, the DNS resolving, we have the TCP handshake, right? So like browser opens a connection. Now it has an IP, so it can open a connection to the server. And the first thing that it does is the three-way handshake, like you have it here. And what comes after is the TLS handshake, right? So like you can see it here. We have both the TCP handshake and the TLS handshake, and they're going to exchange the certificate, see that it's a valid one, everything. But what this means is, like, for every request that we do, is we start with kind of like 200 milliseconds latency. depends on the client and server location, can be more or less, but we can say that maybe it's an average until we actually can start sharing application data. And like, we can share the HTML and everything else. So it's a big latency, right? We start with something with this latency of around 200 milliseconds. And one of the fixes that it was tried for HTTP 1.1 was pipelining. And pipelining meant that the client can send more requests to the server and not just wait for the response to come back. Like we said, the protocol HTTP 1.10, it's the client waits for the response until the next request is being sent. So the pipelining means like it can send multiple requests. Problem that pipelining was not adopted, and the reason is pretty simple. The server had no way of telling the client that it does support pipelining. So like you could get into trouble if you as a browser start sending multiple requests and the server doesn't support it. There is no HTTP header into the server saying, hey, I support pipelining or something like that. So how does the browser, increase the throughput is by, now what they do is they open more connection to every subdomain. So they open 6 connection usually to the server. So now we have 6 times the latency, but we pay it once for each connection, and after that the data can be exchanged. One thing to say is that if you have any questions, feel free to send a message. I will be looking at the messages so we can make this more interactive. So like if you have questions, feel free to ask them and I will try to answer. Yeah, so no pipelining for 1.1, open 6 connection. And this kind of fixed this head of line blocking for HTTP, right? With the client waiting for the response. Yeah, and then HTTP 2 appeared. It is a major version because it's a totally different protocol. It's not an upgrade. It's totally different. It's binary. It's not ASCII anymore. Just one connection. So this means we still have the handshake, but we only do it once. We don't do it 6 times. So that's why it's reduced. We still need to do the TCP and TLS, but only once. Based on streams, so like on the same connection, you can send multiple requests and multiple responses are coming back to you. And the server can actually decide what to prioritize, which of those streams, which are requests, can be prioritized. And it can also do push, even though this didn't catch up too much. I think only chess.com uses it. I'm using it like you can actually do tests there and see like the server pushing stuff to you. So when you're asking for, index HTML, the server does know that there are JavaScript files, CSS files coming, and they can actually start pushing them to you without a request. So like it can be helpful, but for some reason this didn't catch up on the server side. And yeah, besides the body, now we have header compression, and during the demos, we're going to look at the ALPN, which is the way to negotiate the upgrade to HTTP 2. Yeah, so things got a little more complicated, no more ASCII, binary a little bit harder to look at, but it's not that complicated. With the right tools, you can still see the traffic. Yeah. I do see in a browser. I think it depends on the browser. There's some on the developer tools on the network tab that they save the protocol. You can look at the HTTP headers. I will have some demos with curl where like you can see the kind of like everything that is being sent. So like we can look at the headers, and I think like the network tabs usually show the headers, and I think that should be clear. We can try some. I usually use Firefox, so we can look at the network tab. I think Chrome also has like a protocol column, and you can see it. Yeah, this is how HTTP looks like. Only one connections, no more 6 connections open. We're using it much better. We're using the network much better, less resources. And we kind of like fixed this head of line blocking, so we don't need to wait for those requests that are slower. All the others can go without waiting for them. But HTTP, yeah. So a few misbeliefs with HTTP2 is that it's available with only TLS. But there are two versions, two variants. Like there is H2C, which C comes from Clear, and there is a website where we can test this. It's especially for doing tests. The only thing is that the browsers usually don't use the Clear version of the HTTP2 because we have, I think it's called protocol ossification or something like that. The traffic flows through a lot of small boxes that I know, like routers and switches and firewalls. They usually understand very well HTTP1. Some of them are really old, and if they will see HTTP2 in clear, so not encrypted, then they might think it's a problem with HTTP1 and drop the traffic or even try to fix it. So because of this, browsers don't use the H2C, the clear version. They only use the version of HTTP2 via TLS. And ALPN, we'll see it's a protocol negotiation that only works with TLS. So going now to another next one. There is also this misbelief that we need the access to the private key in order to decrypt the TLS traffic, which is also not true because it starts with this asynchronous encryption with private public key, but then the client and the server share a synchronous key. So if we get access to that synchronous key with like synchronous encryption key, then we can actually decrypt the traffic. And there is this possibility offered by, I think it's the OpenSSL library, that if it finds this SSL klog file environment variable, which actually points to a file, it will put the synchronous key, like the key that the server and the client agreed on, it will put it there, and you can actually decrypt the traffic. So this means that it works in every browser, which and because OpenSSL is the most used library, and it works in every browser. It works with curl, but unfortunately, it only works with TLS 1.2, which is still pretty used, but majority of sites now use 1.3. Nice thing is that with curl, we can actually enforce it to downgrade to 1.2. And I will do a little bit of the demos, and if you have questions, keep them coming, so it will be a little more interactive. So let's do like this. And So can you see the text on the?
A bit.
Okay, let's.
Maybe just increase it a bit. Perfect.
Okay. Okay, so let's see the H2C in action. So the website is, I wrote them down, the commands. So something like this. First, we can do the. So now we're saying, okay, use HTTP2. Okay. I will put verbose. I don't care too much of the output, so I'm sending it to terminal. And what I'm doing is, like you see, I'm not using HTTPS, I'm just using the HTTP clear version, something like this. So what happened is my client sent the GET request using 1.1. And what it sent is it's trying to upgrade to H2C, right? That's what you see here, this upgrade header. And we get from the server the switching protocols 101, and it says, okay, switching to HTTP2. So, and now we get the HTTP2 200, also from the server. Interesting is that this upgrade, it's actually not say deprecated, but it's not part of HTTP2 RFC anymore. So I think like 2 years ago it was removed, mainly because and you can see the H2C. So now we have HTTP2 without TLS, and it was removed because usually like this H2C happens in very controlled environments, right? It will not happen over internet because browsers do not allow it, and it will not happen because it's very like it can fail. Some small boxes out there through where the traffic is flowing through might drop the traffic or might try to fix it in some way and damage it, so it will not work if they can actually see it, if it's in clear text. So when it is encrypted, they will not be able to see what's happening underneath the hood, and they cannot do anything to it. They cannot alter it. So what I can show is that if we go to the HTTPS one, so now this is, you can see the TLS handshake very clear. So like, and before there was no TLS handshake, and now we can actually see that the traffic is encrypted. And this is the ALPN. So this is happening before any HTTP request is being sent. So this is happening before HTTP. So, and this is part of the TLS handshake, the ALPN. So, and the here is kind of like the client saying, hey, I know H2, so not H2C, I know H2, and I know HTTP 1.1. Okay, and the server says, okay, I'll take H2, thank you. And then this is coming. And then we get, this is the actual first HTTP call that is being done by the client, and then it gets the server response. While we are here, I will show you also this header, which actually says, hey, I also support HTTP free. It's on port 443, and I support the final version, and I also support draft 29. So this is what it means. So like, if you see this header alt SVC, this actually means that the server can advertise that, hey, if you want to upgrade, I do support HTTP free. Okay. I don't know, anything unclear, any questions? If not, I think we can move on. There is also the possibility to not do the protocol upgrade and to ask for HTTP2C directly or HTTP2. So like something like this. Usually the browsers or other clients we'll try somehow to make it more performant and remember, okay, so this server does support HTTP2, so they can try directly. Usually the safe way is to start from the smaller version, from the lower version 1.1 and try to upgrade. But if you already know about it, like the browsers can try, I know, probably in a few years they will try HTTP free, and then if it's possible, continue on it. So don't need to do this additional round trips. So like I think the flag is so -v HTTP2. It's a little bit bigger. It says prior knowledge, something like this. So I know that I don't care about the output. Okay, and yeah, something like this. So this will go directly and do the get HTTP2, right? And you see like there is no TLS handshake. Here we don't see H2C anywhere specified, but being HTTP2 and without TLS, it's clear that it's HTTP2 over unencrypted. It's not encrypted, so no TLS. Okay, and then there was the SSL keylog file for this. So what we can do is, let me open Wireshark. Okay, we'll catch on my, okay. For now, I will stop it. I see a lot of Zoom doing UDP, which is good. Okay, and you can see that the TLS 1.2 traffic, when it is encrypted, like it is just say encrypted application data. So like you don't know what is there. Like it can be HTTP2. It can't be HTTP free because it's TCP. When we'll see, like you see here, TCP. But it can be HTTP2, but it can be also something else. We don't know. So like if I would see something like, I can filter, like if I would see something like HTTP2, then it will actually mean that it is not encrypted, or like I decrypted it with SSL, the keylog file. Okay. So what I would do is I will file. So I have already a path users that I will remove, and I'm creating there a temporary file. Like you can see that actually there's nothing here, or I have something. Okay, let me delete it. Okay, so now there's nothing here. There is nothing in this folder, and I have the keylog file variable setup. Hopefully I didn't do any typos. Okay. So now what I can do is, I will just do a curl and I will say use TLS 1.2 and don't upgrade, maximum 1.2. And I know we'll just, I don't care again about output, and we can go to Google. Okay, and meanwhile I can start again. So let's see, so something like this. can see it's TLS, and you can see it's 1.2. Let me stop it because too much. All right, so it's not 1.3, it's 1.2. Everything looks okay. You can also see that Google does support page 3. Okay, and I can do something like this. So now I can actually see the traffic being shared with Google. Yeah, some data here. So now it's not encrypted. I think I can. I think I can actually see it here. So you can see the content that I would got in the browser, right? And there's some doodlers. Sărbători fericite, right? Sezonul sărbătorilor de. So I even get like I probably was redirected to the raw, and I got some specific version for December or something like that. So the idea is like we were able to decrypt the traffic. Like you can see now that the file here does exist, and it does have something inside. So there are the keys put there. What it happens is that we would need to start. There's still a lot of traffic on TLS 1.2 that can be decrypted. This is pretty useful if you want like to, like to share like you can save the Wireshark. Like I can save this and share it with someone, which I like to share the traffic and show some problems there, and I can show it unencrypted. Yes, if a malicious party would have access to my computer to set a keylog file, then yes, that would be a problem. Probably if it also has the ability to set an environment variable, it can do a lot of other things, like it can maybe read them. But yes, it is a, I would not say it's a vulnerability, but it's pretty powerful thing. Yeah. Unfortunately, on TLS 1.3, there's still a lot of discussions on how to do it, because the synchronous encryption algorithms are like, there's a lot of algorithms that are being used. So the algorithms used for TLS 1.3 are, let's say, different. And even if you share the key or something, it will not work entirely. That's what I understood. So it still doesn't work for 1.3. But there are like these open items somewhere on GitHub that you can watch. Unfortunately, I don't have a link. Okay. Okay, moving on with the presentation. So this was the keylog file. Okay, so what happened with HTTP2 is now we fixed the problem of the HTTP protocol. So we got rid of the request response issues. Like we don't need to wait for the response to come to send another request, and we don't need to open now 6 connections. It can happen everything on one connection. So less resources, we're utilizing the network much better. But now what it happened with HTTP2 is that it reached the limitation of TCP. So the problem with TCP is that if something is lost, the TCP actually does handle the retransmission. The problem is that if something is lost, everything is blocked until that package is being retransmitted. So like you can see here that like host A sends to host B, like you can see it starts from 92, so it says and sends an additional 8 bytes. And yeah, host B receives and says, okay, I'm at index 100, so 92 plus 8 says, okay, I'm at 800, and 120 somewhere is being dropped. There's some problem somewhere, and it doesn't reach host B. And if host B doesn't get it, like so, like answers 3 times that I'm still at index 100, then host A will actually resend what was at the index 100, something like this. And everything on that TCP connection is being stopped. Everything doesn't until the host B actually says, okay, I am now at 120. So now everything actually it will not be at 120, it will be at 141 plus 16, because all the others are like waiting. They're like saved somewhere in some corner of memory, and like, but it needs to wait for 120 to actually be able to process them. So until 120 gets to the host B, everything is stopped on this network connection. So like, yes, we solved the head of line blocking for HTTP, but now we have this TCP issue with head of line blocking for TCP, which is kind of, in a way, this is the feature of TCP, but also kind of its weakness. So, and this, the retransmission part plus the congestion control is actually the thing that TCP offers you besides UDP. So like on UDP, you don't have this retransmission. You send something. If it gets there, is good. If it doesn't, I know that's nothing we can do about it. And there's also like this congestion control. So when the traffic starts, it doesn't send a lot of bytes. It starts with very small number. There's like there are variables that you can set this, but it starts very low. And then with every acknowledge that it gets successful, it increases this size. But this means that why it is doing this, because all these firewalls and routers have a processing power, and if they can't deal with it, they will put it in queues. They will queue it and wait until it gets to process it. And of course, that queue is not infinite memory. So at some point, it will run out of memory and stop dropping the packages. So we don't want to flood the network. There is no point in just throwing a lot of packages if not a lot of packages, but a lot of big packages, let's say, if the network can't handle it. So it's also like when something like this happens and TCP doesn't get the right acknowledge, the host A actually also reduces the package size. And so these are the things that they're trying to fix for HTTP 3. Of course, like you can change and make TCP protocol better. And let's say, okay, you can find ways to fix this retransmission to make it better. Network did improve, so maybe also the congestion control, you can actually start a little bit higher. But the problem is such changes to a, let's say, very mature protocol would take probably years. There will be a lot of discussions. And I know technologies like Zoom or YouTube didn't have years to wait. Like they need, streaming is very network heavy. So like, if you want to watch a YouTube video with 4K, something like that, it needs a lot of traffic. It needs there is a lot of packages being sent. So of course, like what can you do about it? Then you can go to UDP. So this is how HTTP3 was actually born, by moving what we did well on HTTP2, moving it over UDP. So if you move it over UDP, you don't, like we say, we don't have the control anymore, the retransmission, we don't have it. So what you do, if you don't have it, you kind of need to put it in the application part. Right? You still need to create it, but now it will not be part of the protocol, so it will not be in some kernel libraries, it will actually be in the application layer. So this has some, some negative performance, but okay, not too much. So that we have a new protocol, Quick, which actually means that it has the TLS part inside, it has the retransmission part inside. Only supports TLS 1.3, cannot work with 1.2. Interesting is now, because we have a new protocol, we can bring it to up to date. So it's not reliable on the IPs anymore. So it can actually use some connection IDs at the quick level. So this is how you can start watching a video on your mobile on your home Wi-Fi, and then go outside and switch to do like automatic switch from the Wi-Fi to your mobile network, and you can still see that video. Like, it might be some pause, but it will resume from where you left. So this is because even though your IP has changed, and this is because it does use some other connection IDs behind. Like, we will see it. All the major browsers are using it. It's not in beta anymore. So like we saw that there is H3 without any draft version. Latest was 29, but now we don't have it in beta. So it's a full protocol now. Everybody can use it, and all the major browsers use it. There is just not Safari, which until maybe 1 year ago had it in the experimental feature, so you are able to go there and enable it, but now it's not in experimental features, and it's not also enabled. So there's nothing you can do in Safari unless you are some of the lucky ones that got it rolled out. So I understand that they're testing it, but all the other browsers already use it. So if you're watching YouTube, for sure you're using HTTP free. If you're watching YouTube on Chrome, you're using HTTP free. How do you go from 1 or HTTP 1.1 or 2 to 3 is we saw the alt SVC HTTP header. This is how the server says, okay, I support HTTP 3. So if you want to go there, just use these settings. It's UDP, so it's still port 443, but it's not TCP anymore, it's UDP. There is also a more, not necessarily experimental, but it's not such so used DNS resource record. It's called HTTPS. I can tell you that Route 53 on AWS doesn't support it, but it is a valid resource record. And with HTTPS record, you can actually say that, yes, my website, google.com, does support HTTP2 and also HTTP3, and you can find it here, something like that. So you can, the browser would actually need to do, besides the A or for A query, would need to also do the HTTPS query. If it finds something, it will actually know to go to HTTP3 directly. And probably down the road, like we said, the browsers are going to try at some point HTTP3 if there was some prior connections to the server with HTTP3. So they're going to probably try it directly, and if it doesn't work, downgrade or something like that. So not necessarily like start with 1.1 and then do the ALPN and reach HTTP3, or I mean, it might be directly HTTP3. So they're going to do this try. The bad thing is that curl doesn't support it unless you build it by yourself, right? So like there are there is documentation on how to build it. It's not easy because the problem is not with curl. The problem is with the TLS libraries. OpenSSL still doesn't support it. Doesn't support Quick, and because of that, there are some other libraries. I think probably one pretty known is Quiche from Cloudflare, but you need to build it. You need to build curl with this library. And let me see if I have it here. Like, you just Google curl with HTTP free, and you can see it here. The problem is it's a little bit complicated to find the right version, because here it's kind of like text latest, which doesn't always work. Sorry. So like it's a little bit tricky to find the right versions. I have it built locally. So I have something like this. So Quiche is 0.12 and curl is 7.82. So this would actually work. Yes, and you need to have the features HTTP free here. So on my normal curl version, on the 8.1.2, I don't have HTTP free here. And it also doesn't use this library. Okay. So what I can actually do with curl free is I can ask for, I have this additional flag. So I can ask, let's do the verbose. Again, I don't care about the output, and we can try, let's say, Google, and we can see that it asked for, we can say that it asked for HTTP free, right? We can see some ALPN. This is what the client supports. So a lot of drafts, but also the final version, and okay, then we see the actual HTTP request, and then we see the response. Okay. So this is what happens. If you have other questions, if not, let me see where it was. Okay, here. So what's the current state? This was more beginning of summer, I think, or until May, something like that. So you can see here the kind of what Cloudflare has some statistics, and you can see that HTTP free is over the internet at least, somewhere at 40%, which is pretty good. So this is kind of like the browsers using, let's say, websites. On API, it is a little bit different, and this is also the current state where I'm working. So we have the static website. It is over HTTP free, but the API, it's a little more complicated to bring it over HTTP free. There you have like more network security to open UDP. I mean that like the static website, it's usually hosted on some CDNs, like CloudFront from AWS or like Cloudflare or something like that. So like usually there is just one checkbox, use HTTP free, so it's not hard to enable. On the API side, it's a little more complicated, and probably also the benefits are not that big because you don't have so many resources to query. It's like a major website can have 100, 150 requests being done, and not so many API requests. Yeah, usually the protocol, yes, it's the client who says, okay, I'm using this, but the client usually, like, I'm answering this question, how is the protocol version negotiated? So usually it starts from what everybody knows. It usually starts from 1.1. So like if you go to your browser and type a website that you have never visited before, it starts 1.1, no TLS, no HTTPS, nothing. Unless you write, of course, the HTTPS. So like if you write google.com and you have never visited before, it will go to 80. Then there are some headers like the, there are some headers that say, okay, from now on, you'll know that it does support TLS. So next time, please, the browser will use TLS directly. I think there is also a list on the browser or something like that. And it will upgrade to HTTP 2 or 3. Depends on what the server tells. Like, I think it will, if it supports 3, it will go to 3. If it doesn't, it will go to 2. The next visit that you're going to do, the browser should remember this and go with 2 directly. But this is kind of not part of the necessarily of the protocol description. So it's not part of any RFC. This should probably be kind of some browser performance thing, right? It's, okay, this website does support HTTP 3, so I don't need to start again from 1.1, do all these round trips just to upgrade to 3. I can start directly on 3. But normally it's like, let's say, by the book, by respecting the protocol, every time you start 1.1, there is the header just to specify that from now on use TLS. So 1.1 on TLS and then do the upgrade. But I expect that the browsers will skip this part just to be much faster. I don't know if it answered completely or like if you have more things unclear. Okay, great. Yeah, so this is kind of the situation. Let's see. Okay, so yeah, the advantage is something like on the CDN side, the website is easier to do it. If you are hosting on a CDN, yeah, like I said, it's just one checkbox. On APIs, more complicated. Depends what you have behind the hood, but there's usually some proxy, some API gateway, something there that needs configuration. Also the network part, if you're allowing, usually you're allowed TCP for free. Now you need to allow also UDP for free. Yes, and it's probably some discussion with security if you want to have that enabled. So yeah, APIs will follow a little bit later. But I think like from my point of view, if you have a static website hosted on a CDN, it would worth enable it HTTP free. Okay, so and that's it. Like if you have any more questions, I would happily answer.